In this video, we are going to be doing derivatives on a challenge problem. So this is the challenge problem. What is the derivative of x cubed minus 1 times cos of x squared all over x plus 4? So this might seem really easy, but it's actually really hard. It took me a long time to solve it. So pause the video and find out for yourself how you would solve it. Okay, hopefully you've paused the video, and so far I'll give you 3 hints, right? Or not hints, since you've probably already done it, but you should have, in your solution or your work, you should have used the product rule, combined with the chain rule, so these two, and then in the second half you should have used the quotient rule. So those are the 3 that you should have used. Hopefully you used them, and so let's get started. First, since we need to use the quotient rule, I'm assuming you know what the quotient rule is, but in case you don't, this is what the quotient rule is. Okay, so the quotient rule states that the derivative of u over v, actually, let's not do u over v. I'm going to do f over g, since I'm more familiar with that. So that is going to be, for that derivative, we have to do the derivative of f, which will denote by the tick mark on the top, or as I like to say, it's prime. So f prime times g minus g prime times f. And this is all going to be over g squared. Okay, so hopefully you done that. So that is how we do that. But now what we have to do is we have to first, since the f, so basically this f corresponds with this entire numerator. So we can't really do anything with the numerator if we first, since we need to find the value of the derivative of the numerator. So first we need to find the derivative of the numerator. So yeah, let's do that. Okay, so for the numerator, we have to use the product rule and the chain rule. So let's get started. So for the product rule, so that just states d over d of x. So d over d of x of the function of f times g is equal to f prime times g plus f times g prime. So, for this, we need to find the value of f prime. We had to find the value of f prime, g, and g prime. So let's get started. So the value of f is just this. That is going to be x cubed minus 1. The value of f prime is going to be 3x squared. And the value of g is going to be cos of x squared. And for g prime, this is where it gets tricky, but g prime, all you have to do is actually just apply the chain rule. So applying the chain rule, I have a video on the chain rule, I'm going to make a video on the chain rule, but in short term, the chain rule is d over d of x, and this is used on composite functions such as the cos of x squared. So that basically states if f of g of x, so f of a composite function, so for us the f would be the sine and the g of x would be the x squared. Anyways, that would be the derivative of f times the regular value of g of x times the derivative of g. So yeah, that is that. So yeah, that's the power rule, not the power rule, the chain rule. So if we apply that, so as you can see, we have to first find the derivative of cos. The derivative of cos is negative sine. So it's negative sine times x squared, and then the derivative of x squared is 2x. But then this would equal negative 2x times sine x squared. Okay. Now we erase this part since this isn't needed. Okay, now that we have our values of f prime, g, and g prime, we can start finally applying the product rule. So yeah, let me erase all of this since we're done with the chain rule. Okay, so for the top, I'm going to be denoting this entire thing. Since this is going to be taking really long, I'm just going to be doing the Greek symbol here. Okay, so this just represents the function, and since that's the derivative, so from before, let's say Yeah, so we're just finding the derivative phi, or phi, however you say it. It's the Greek letters, so it's the 20th Greek letter. Basically, this is going to be representing, this is going to be equaling, what was it original? X cubed minus 1 Okay, so that is that value. Now we have to find that derivative by using the product rule. So that would be 3x squared. Yeah, 3x squared times, and now it's g, so cos x Dude, what did I just do? Oh no. I like adding the parentheses there because it just makes it look more clean. But anyways, cos x squared plus the normal f, so that's x cubed minus 1 times what was a negative 2x times sine x squared. And this time I'm going to be putting this negative 2x as a group itself. Okay, now we have to simplify. Just want to make sure I'm drawing this correctly. Okay. So this equals 2. Mostly everything's actually the same. So we only shift some variables. So in the middle, the plus sign is still there. So this is still here. But now we shift, we write minus 2x times sine x squared. Okay. And now that we have that, we use this derivative for the quotient rule. So now you're understanding why this is so tedious. So let's bring this rule down. We used f and g last time, so I'm just going to remove the f's. And plus, for this time, instead of using f, we used phi, or phi. Okay, so we use that, and now, yeah, let's replace this, because we already use these values. We don't want to overuse them. Otherwise, our work in the end would, work at the end would look very weird. So I'm just replacing them with alpha. Okay, so now we actually do the derivative. So the derivative, first you need to write down all the values of phi and phi prime. So phi is x cubed minus 1 times cos of x squared. Okay, and next we do phi prime. So that's phi prime. And now we do alpha. And alpha, if you remember from before, that was the denominator. So we're lucky and we only have x plus 4. So, x plus 4 and alpha prime is 1. Now we can start constructing our question. And I'm going to move on to the next page, since this is where the hard part begins. It's honestly just the calculation. If you do have like the Inspire, I don't, but the Inspire can definitely simplify. I don't know if the TI-85 can simplify, the TI-85 Titanium can simplify questions like these, but you guys can try. Let me know in the comments if it does. Anyways, so if we construct everything, in the end we get, okay, so now the Greek letter I'm going to be using is psi. So this is going to represent phi over alpha. That this is going to be the derivative of that. So yeah. So symbolize it as that. This is just used to make it so we don't have to write d over dx in the question again each and every time. So yeah. Okay. So for the first one, we have phi prime times alpha. Remember to write in the parentheses. Okay, and now it's minus alpha prime times phi. So since alpha prime is just 1, we can just write phi. And for the bottom, we just have alpha squared, so it's just x plus 4 squared. And now this is where we combine terms. So bear with me, this is going to be taking a long time. Just analyzing my notes right now. Okay. So you know how we have this entire, I guess, section? So what's going to happen is this is going to get multiplied to this term or section, and this same term is going to get multiplied to this. So hopefully the highlighting made you understand that. So let's apply that here. And everything else will just stay the same. So I'm just going to copy and paste this. Okay. So starting off, we have the term of 3x squared times the value of x plus 4 from here. And that's timed cos of x squared. And now it's minus 2x multiplied by this term I need to move this here a little. And then it's just multiplied by the rest of this. Okay. Am I missing anything? Yeah, I'm missing a parentheses here. Okay, so that's there. X cubed minus 1. Okay. Next, we just have to simplify everything. So we have to multiply this on here and multiply this on here. So again, I'm just going to duplicate this and erase the parts that I don't need or are getting changed. So when we multiply, we get 3x cubed plus 12x squared times the cos of x squared. minus, and now what two terms? These are the two terms getting multiplied. Yeah. Times x cubed minus 1 times sine x squared. Making everything sure it's correct. And yeah, and now you might think we're done, but first let's understand that there's these terms, and these terms. Okay? And for these terms, this term and this term, they both have, so they both have a cos x squared. Cos of x squared. So we can technically factor out that and simplify our equation more. So yeah, let's get to that in the next step. For the next question, I'm going to erase the entire numerator after duplicating it. Okay. So if we take out the cos x squared from this term and this term, we'd be left in the numerator with, open parentheses, 3x cubed, 12 squared minus, so yeah, that's the first part, and then minus x cubed minus 1. And this whole entire thing is multiplied by cos of x squared. And this is getting subtracted by this. Okay. Now that we have that, we need to combine these terms. So I'm going to be duplicating everything again. So what happens is these signs will change. So this will become minus and this will become plus because we remove the parentheses. Okay, and now in the final step, for the final step, we are going to have this will simplify down to 2x cubed plus 12x squared plus 1. And this is the final answer. Yeah, and we should probably move this up to the front. Yeah, and this is the answer. So yeah, that is the answer to our challenge problem. Thank you for watching. I hope you learned a lot, and goodbye.